In this example, we're going to go ahead and verify this trigonometric identity. And in looking at these two sides, it seems like they have a lot in common. So this left side is a fraction. We have cosecant of n plus 1 over this cotangent of n. The right side looks almost exactly like its reciprocal, with one exception. Instead of being plus 1, this is minus 1. So which side should we use to work with, and which side should we make it look like? So let's go ahead and use this right side. We'll manipulate it into looking like this left side, and that's how we can verify this trigonometric identity. Let's go ahead and start by, it looks like we have this cosecant n minus 1, and ultimately we need this denominator to be a single term. So let's go ahead and multiply the top and bottom by the conjugate of the denominator. So I'll multiply it by cosecant n plus 1. And one reason, again, was that we noticed we had only a single term here and two terms here, and we would like to create a situation where we can just have a single term. So doing this multiplication here will leave me with a nice Pythagorean identity. Also, here's one big reason, is now we're multiplying the numerator by cosecant n plus 1, and look, cosecant n plus 1, that's what I want it to look like. So the goal is now, I guess, to cancel this out somehow, so we just have this in the numerator. So let's go ahead and see what we have. So we have cotangent n, and I'm not going to distribute that through because my numerator almost looks the way it needs to already. But the denominator is going to be cosecant squared n minus 1 when I multiply through. We do have a nice Pythagorean identity that I already mentioned. We know that 1 plus cotangent squared n equals cosecant squared n. Okay, so I need this to look like cosecant squared n minus 1. So let's go ahead and subtract 1 from both sides of this identity. And it looks like we have cotangent squared n equals this cosecant squared n minus 1. So this is the denominator that we have, and this is the replacement that we can make, or the substitution. So let's go ahead and do that. So in our numerator, we have this cotangent of n times this quantity that was cosecant n plus 1. And now our denominator is cotangent squared n. All right, well, one of these can cancel with the squared. So now we just have cosecant of n plus 1 divided by cotangent of n. And if you look at everything together now, that's exactly where we were headed. So we are done, good to go. We have verified this trigonometric identity. So let's go ahead and kind of recap the steps that we took. So we started by multiplying the numerator and the denominator of the fraction on the right by the conjugate of the denominator here. And that helped us do a couple of things. One, it helped us set up a Pythagorean identity where we could exchange it from two terms down to just a single term. Also, using this conjugate gave me exactly what the numerator needed to look like on this left side, the cosecant n plus 1. Okay, and then from then it was just a matter of simplifying, and here we are. So there's this example of verifying a trigonometric identity.